My name is Siobhán McHugh and I'm the CEO of the Demand Response Association. So I'm going to give you an overview, I suppose, of where we've got to in Ireland in terms of demand response. Um, that's across both the power systems of Ireland and Northern Ireland. So first of all, let me just outline the trade association that I represent. So our members operate in the wholesale electricity markets on the island of Ireland, that's known as the SEM. They are NLX, ESB Customer Solutions, Grid Beyond, Veolia, and Viotas. And they hold capacity contracts for approximately 700 megawatts of capacity. So those would be in forward timeframes. In the current capacity year of 21-22, that's approximately 450 megawatts of derated awarded capacity. And at any one time, you will have 150 to 220 megawatts available. And just for comparison and for you to understand, I suppose our peak winter demand is approximately 5.5 gigawatts on the island system. The client base of the demand sites that are aggregated within our members' portfolios are primarily industrial and commercial customers. So generally the sites would be a minimum of about 1 megawatt of response up to almost 10 megawatts. And those trade together in units in the electricity market aggregated by our members. Participating customers come from several different industries, including pharmaceutical, large manufacturing, data centers, mining, cement production, agri-food, and other large customers who have significant heating, cooling, pumping, or other large machinery loads. The response can come from on-site generation, so assets such as combined heat and power, anaerobic digestion, diesel generation, or sometimes generation fueled by hydrotreated vegetable oil, as well as on-site battery storage, controlled process interruption, and electricity use interruption or reduction. So in terms of the power system in Ireland and Northern Ireland, I suppose we face two major challenges in the coming decade. The first of these is to achieve electricity decarbonisation on an island system, which has limited DC interconnection to other power systems. I'll talk about that a little bit later. And also achieving this with high levels of generation from variable renewable electricity sources. And for us, that's primarily wind. The second challenge is one that we all face right now, an immediate term challenge around security of supply. So this is always somewhat of a concern in Ireland, given that we produce the majority of our electricity on the island. And as I said, we have limited interconnection, in this case to the GB power system. This challenge is even more now as we look at the issues facing us in terms of fuel supply from other regions. So, firstly, let's look at some facts and figures around the current generation mix that's supplying our electricity demands in Ireland and Northern Ireland. The latest whole year figures available are for 2020, and they show us that approximately 30 terawatt hours was generated over the entire year. The vast majority of the power generation came from gas, almost half, 49.7%, and renewables at 43.4%. And as I said, the overwhelming majority of renewable generation in Ireland at the moment is from onshore wind. So while these figures might be lower than usual in total generation for 2020, given the impacts of COVID-19 and the pandemic, the overall generation mix is actually quite representative of a typical year on our power system at the moment. So you might be asking, where is the demand response? And the answer to that is that it sits in the other category, the very small percentage of the total overall annual generated megawatts. But nonetheless, it's important as part of the power system providing system resilience in the form of capacity adequacy and system services at times of power system stress. The key benefit of demand response at the moment is its ability to provide adequacy when most needed. So it helps avoid the high cost of building new power generation plant when these services can be sourced from demand customers. In our case, primarily industrial and commercial sized customers. This is done at a fraction of the cost of building a new power plant and also considerably less carbon emissions compared to building, operating such a plant over its entire lifetime. Next, we're going to look at the kind of markets that demand response and flexibility operate in. So, where can demand response provide a service and earn revenues within the wholesale electricity markets in Ireland and Northern Ireland? So firstly, key among these is the capacity market. This provides an annual per megawatt per year payment of approximately €45,000 for capacity that is successfully awarded through an auction mechanism. This is done as far out as 4 years in advance for the capacity year in question, can also be procured in intermediate timeframed auctions from 3, 2 and 1 year in advance as well. Secondly, demand response provides much needed system services. In the SEM, these are called DS3 services, but essentially they're system or ancillary services. This is primarily in the form of fast frequency response, ramping, and replacement reserve. These are procured using auction mechanisms which run at least twice yearly, and in demand response can compete and be awarded contracts and is paid a regulated tariff for provision of the service. Thirdly, we have the energy market. So that's the provision of megawatt hours when dispatched by the system operator. As I said, demand response tends to be used for this service at times of system stress, what we would call seldom and severe events, when capacity margin is very tight on the power system, and in our case, usually when wind is low. In a typical year, this would operate approximately 10 times and would be expected to occur most frequently in the winter and over peak periods where additional megawatts are required to meet demand. We expect that this coming winter, demand response will be used more frequently due to overall capacity shortage on the power system. And finally, although it does not exist yet, there are plans to develop local flexibility markets via our distribution system operator. So these will use demand response services to help ease congestion on the distribution network, help manage power flows between distribution connected sources of generation, such as solar and wind, and an ever-increasing amount of electrified sources of heat, such as heat pumps or transport in the form of electric vehicles, all of which will be connected to the distribution system. Now that we've described how much demand response operates on our power system, the kind of services it can provide and the kind of clients that participate, I'm going to delve a little bit further into what the future looks like. So let's look at the future ambition on the power system and the role that demand response and flexibility can play. I've taken 2 example years here of 2020 and 2030 to illustrate, I suppose, where we are now and where we're going to next. So firstly, let's take a look at where we are at the moment. So in 2020, having overcome a lot of technical challenges, I suppose, on how we operate our power system with extremely high levels of variable renewable generation, mostly in the form of wind on the power system, we are now looking to go even further up to 2030. So firstly, if we look at system demand, that's predicted to rise, stemming mainly, I think, really from that increased electrification we've already talked about, both heat and transport at a residential and commercial level, but also demand across the year is predicted to rise as well. That is going to be driven by increased industrial customer growth and large users on the system, mostly in the form of data centres. Now, if we shift it to looking at the generation mix, what we can see is the amount of onshore wind will significantly increase. We will also be connecting an awful lot more of onshore solar at a grid scale as well. And I suppose looking further down, the grid operators have also identified the need for additional battery storage to be connected at network level, and for there to be an increasing requirement for demand response in order to provide services and capacity adequacy. It's predicted that we'll have additional DC interconnection from Ireland to both France and GB, so probably in the order of an extra 1.2 gigawatts. Currently, we are just connected to the GB system via 2 existing interconnectors, just under a gigawatt's worth. And finally, we will have a large amount of offshore wind generation in 2030. That's going to require its own connection points to the network and a significant level of grid infrastructure to manage and to use that generation. Lastly, in the bottom section, let's look at the system targets. So in terms of levels of renewable electricity generation, the 2020 target for Ireland and Northern Ireland was to achieve 40% RESI. That is an average of 40% of the annual power generation from renewable electricity. And as I said before, in Ireland, that's mostly onshore wind. In 2030, in order to meet our decarbonisation targets, we'll have to move to achieve 80% of RESI generation over the year. And that's going to come from onshore and offshore wind, from solar, as well as I've mentioned above. So that is going to be a huge challenge on our power system. And it's going to drive, increasingly difficult and challenging technical characteristics that our system operators will have to operate. So first of all, it will reduce our system inertia floor considerably. and that might be of much interest to our colleagues from the TSOs in the audience. Finally, we need to reduce the number of thermal units in operation at any one time on the system. So currently there's a minimum requirement for 8 thermal units to be operating. That will reduce down to 5. So this means at any time it's likely that the power system will be operating with an extremely high level of variable renewable non-synchronous power generation. Currently, we have a metric called SNSP, so the system non-synchronous penetration level, and that takes account of generation and interconnection in relation to total demand. Right now, the power system on the island of Ireland can operate with up to 75% of demand met by non-synchronous sources at any one point in time. And I'll pause on that number for a moment and let our system operator colleagues consider the technical challenge that presents, that large amount of non-synchronous generation. In order to move forward and achieve the 80% RES-E targeted in 2030, the objective was going to be at times to achieve stable power operation of the system with up to 95% instantaneous penetration of non-synchronous sources of generation. So where we look at where the system will source the required system services such as ramping, operating reserve and frequency response, key providers of these will be flexible sources such as demand response, as well as grid scale battery storage and other technical devices such as synchronous compensation. What's extremely clear is that demand response will play a key player in helping the power system operate safely and securely at extremely high levels of variable renewable generation. Equally, when we look at the more immediate challenges of the winter season ahead of us, demand response will be critical in providing capacity during critical peak times, keeping the lights on and the electrons flowing. So finally, thank you all for your attention and your interest in the presentation. I hope it's been interesting to see how much we've achieved on the power system in Ireland, and that we're seeking to go even further in terms of the technical challenge now up to 2030. For myself and for the members of our trade association, it's clear that demand response is an essential part of the equation that's going to help us get there. And I hope that we've given an example of how to successfully integrate renewables and facilitate decarbonised sources of electricity generation using demand-side flexibility. Thank you.
Siobhán, thank you very much for your presentation. Very insightful. I have a few questions prepared. We have some questions from the audience as well. The first question, obviously, you went through the transition in Ireland from the country that didn't use demand response, and now you are one of the leaders in Europe. What were the mistakes you made we should avoid?
Okay, so great question. I suppose I should also take, to be clear, I actually worked in the TSO when we operated some of our older demand side schemes as well. So I'd say one of the most successful things we have is that demand response can now operate in those markets, in the capacity market, in the system services market. And we do have issues and we still have some obstacles to overcome, but it's working. In the past, the demand side schemes were run as, winter peak shaving schemes or very specialised schemes for demand customers only, and they were kept quite separate. I think the one thing that really unlocked that and was really, really important was not linking demand aggregation and those companies like my members who trade in the electricity markets now. There was previously a requirement that they held a supplier license, and that was a major barrier. So it meant it was really, really difficult to operate. We changed the rules of how you could operate in the market. We removed that requirement to have a retail supplier license. And you can see from about 2013, when we had maybe tens of megawatts, we now have up to several hundred operating in those markets. So I think the key thing was removing that requirement for sure. What I'd say is mistakes to avoid is look at all the other examples of how the markets operate across Europe. And I know you have McHugh Villa in later, and McHugh will give an overview of that. But there are some great elements of those markets where you have to really consider you're no longer dealing with conventional power generation. These are not big machines. They're dispersed assets. They operate differently. They provide equivalent services, but you have to write the rules to respect the nature of them and make sure you're not just designing something for large machines. Or in our case, we overcame a lot of technical barriers in integrating wind, and now that's really well understood on our power system. The next thing we need to do is go further and I suppose remove some of those barriers for demand response. So I'd say we've achieved a lot, but still lots to do as well.
Okay, thank you. What is yours or Irish view on integrated and independent aggregation?
We think it's essential. Like, aggregation has really been the thing that has opened up that unlocking of that willingness of demand customers to be able to participate and provide services to the system operators. So in the past, as I said, we operated schemes and it was individual sites signed up and said, I'll turn off some processes, or I might operate my generator over the evening. And, those things are quite, can be a little bit technically difficult, or can be challenging for sites that really are trying to serve another purpose. They're trying to make a product or produce something. Aggregation is the key. The expertise that sits in the aggregators, their ability to be able to do that trading side of things, and also take a lot of the worry away from the customers. So the customers say, like, sign up and they have a technical specification of their site. The aggregator then helps to manage that in a format that's really useful to the system operator. So I think aggregation has really been the thing that's unlocked so much of that potential on the demand side.
Okay, and I know it's going to be a guess from your side, but if you should, estimate how many megawatts of flexibility you would have in Ireland if you had integrated aggregation, not the independent aggregation, what would be the difference compared to status quo, you think?
By integrated, what can you tell me what you mean? The difference is? Maybe I haven't understood.
Into the place as well. So it's a.
Sorry, I just lost the audio there for a second. Sorry.
That integrated aggregator is someone who is steering the flexibility and supply the power as well. That's so, and independent is the two things are separate.
Yeah, so you mean in terms of having some generation and different types of form of service provision all in one portfolio? Yeah, it's really important. I suppose across our members, they have different types of assets operating on those client sites, having different kind of technical characteristics, different durations, different ability to be able to ramp and provide services, be they really fast or really, longer duration. It means they can offer more to the system operator, and it means that they can kind of give a more balanced effect across their portfolio. So I think it is important. Like, we certainly see it here. Demand response started very much as kind of older industrial backup generation assets, but it's evolved. It's become a lot more technically, I suppose, sophisticated. It now controls processes. We've got behind the meter batteries, got a lot of different kind of data and analytics that go into it. And it provides a really stable service. That's the important thing, a stable service into the power system. So yeah, I think it's, that diversity of assets is very important. Some different companies and aggregators will operate a little bit differently, have different specialities, but they all have a place in that market to provide services ultimately to the system operator.
Okay, thank you. And very last question from the audience. What are customers' biggest concerns when approached to participate in DSR?
Yeah, that's a great question. And I did a full panel discussion with someone from one of our member companies on this very thing, because I think obviously lots of companies are focused on energy efficiency. So from their environmental and kind of social requirements and things they want to stand for as a company, and also from a money saving standpoint, as we see the prices going up ever higher at the moment. And they kind of understand that, and they understand efficiency and process efficiency. I think they see potentially demand response as just they don't quite understand it or find it a little bit more confusing. And I think that the really important thing from the aggregator, the partner that you would have in that, is losing the fear factor, not being afraid of taking part, because you have a business as a client demand site, and you're producing your product or storing it or whatever you're doing, transforming something using power. You don't need to be an energy expert to take part in demand response. The aggregation and the kind of sophisticated levels of control and predictability and trading ability that the aggregators have, they can partner with you on that. So we would always say, it's always worth exploring what are your options. If you've already done energy efficiency, maybe there's more you can do, and flexibility depending on your assets or your process type. talk to an aggregator, investigate it. You don't need to become an expert yourself. They will do that part of the work for you, and really don't be afraid. We've seen, as I said, I listed out lots of different industry types that that we see participating here across quite heavy industry, more sophisticated technical industry. We have everything from data centers to cement production, and they all have a part to play. And not any one site there does not need to be the expert themselves. You partner with the right people, and you can provide a service. And it really, really is important. It provides huge flexibility to the system operators, and it's much lower cost and easier to deploy. So it benefits everyone. You can earn revenue, you can provide a service, and you can kind of feel good about helping to decarbonize as well the power system that you're part of.
Thank you very much, Siobhán, for your participants. Great presentation. Thank you. Bye-bye.
Thank you so much.